Hello, and we're live. A couple of minutes early, but let's get started and doing something. So welcome to another Clojure study group. You're finding this useful. We seem to be getting a few more viewers watching, so that's great. And please let me know if there's any particular things you'd like to see in the study group. Happy to try and do what people are asking for. We've got a few requests already, so I'll try and do that. I'm not following on from the API series I started. I'll start hopefully doing that next week again. This week we're going to do some 4Clojure exercises. I'm a little bit tired from the Clojure Bridge event that we did this weekend, which was really great. And so we'll do something a little bit more simple for my little worn-out brain. Let me just share my screen. There we go. If you want to know more about Clojure Bridge, then it's clojurebridgelondon.github.io. We've also got some nice little, very simple install guides for editors, for the editors that we recommend. And so there's a few editors that we suggest using. So there's Atom, Visual Studio Code. That's really, really nice. It's there's a lot of effort gone into something called Carver, which is a nice plugin for Visual Studio Code and gives a really nice experience. I think this is especially good for the Windows operating system as well. If you've got Windows on your laptop, that's a really good tool to use. You can use different shells. You can have Lightning installed in the Bash shell and use that as well. And they're adding more and more features every week, so it's a very active project. There's obviously Emacs and IntelliJ, and there's also a link to Vim. I haven't really used Vim that much, but there's a nice if you want to use Vim and Fireplace, there's actually a nice document here on the Clojure Docs website that goes into a lot of detail about how to use Vim from the along with to do Clojure development. Okay, oops. So let's get back to 4Clojure. So we've done, I think in previous videos, we've done up to 26, not necessarily all in the same order, but they're all in there in previous videos, and I'll link to the different ones. I'll add that to the show notes after the video. So we're going to do 27, 29, and 30. I'm going to come back to 28. It's basically 28 is talking about flatten, and there's quite, oops, that's not 28. Talking about flatten, and that's an interesting discussion at the moment about whether you should use flatten as a general tool, because it's quite a general way to flatten a collection. So if you've got nested things and nested collections within collections, you can use flatten to just like simplify, make everything the same top level. Although some people are saying this is quite a blunt tool, it's quite an unintelligent tool, so you should really kind of flatten or transform your data structure in a very specific way to do with the business or the algorithm that you actually want to flatten that data as well. So I'll do a separate video on 28 for now. So let's look at 27. Palindrome. Again, this is one of these challenges that is quite common in these kind of exercises, is to take a palindrome or test if something is a palindrome. And if you're not familiar with the term, a palindrome is basically something that is the same one way as it is the other way. So if you reverse something, then it should read the same as it was before you reversed it. So race car is a palindrome, because if you reverse it, then race car is R-A-C-E-C-E-R-E, is the same forward and backward. So we just want to, so it's basically asking us to write a function to basically test whether these pieces of data are actually palindromes. So let's have a look at that. And it's giving us a hint. So we'll talk about this. So this race car thing as well. So this is a string enclosure in double quotes. Anything in double quotes is automatically interpreted by the Clojure reader as a string. But a string is also interpreted by some of the functions, especially in Clojure core, in the core of the language, as a sequence, as a collection of specific characters. So it's a collection of R, A, C, E, C, A, R as individual elements in the string. So we do need to be aware of that. And here as an example, so if we do something to race car as a string, and the result we get is a collection of characters, that is not equal to a string itself. So there's a difference there. So we do need to be a little bit mindful of that as we go along. I'm just going to drop into my editor, and I'm pushing these discussions to GitHub as we go along. And I've got my REPL running in there as well, so I can evaluate code as we go along. I'm just going to make that a little bit bigger. There we go. And so I just copied this is just the text of the 4Clojure exercise. And so we've got 3 tests that we need to pass. So we need to do, oh, this is the wrong exercise. Oops, sorry. Where are we? I'm getting ahead of myself. I think I need to tidy this one up. There we go. So let's copy this in. We copy this in. One thing to do if you are copying and pasting into your Clojure editor, just make sure you get the brackets right. Otherwise, it can cause interesting side effects if you miss a bracket off when you're copying and pasting. A comment. There we go. And a little bit. There we go. We've got 1, 2, 3, 4, 5 tests that we need to pass. And so essentially, if you haven't done 4Clojure before, you just need to put something in here to replace these 2 underscores with a function, either a function from Clojure core or a function we're going to write. And it's going to take this as an argument and give us a result. And that result should be, if it returns a false, then this test will pass, because a false on a false Boolean value is going to return true. And this needs to return true, and so on. Because obviously, if we reverse 1, 2, 3, 4, 5, we get 5, 4, 3, 2, 1, and that's not the same. That's not a palindrome. These 3 are, and this one isn't. Okay. Any questions so far? No. No. Good. Good to go. There we go. I just have a kind of standard template I use to kind of document these as well, just using a snippet in Emacs, in Spacemacs. So yeah, so I've got a whole bunch of experiments I've been doing with this as well. Put those in there. So what is the problem that we're actually trying to solve? We want to, I guess we want to reverse the argument that we're passing into a function, and then compare. Compare the reversed argument with the original. And and then we'll return either true or false. I think that's it. I think that's all we need to do. So we can use reverse. There's a reverse function that's part of Clojure core. Excuse me. So we can use reverse. That's part of Clojure core. Let's have a look at that. Ooh, that's not working. Where's that working? And so this is a simple way for us to see whether something is the same. So if I do, oops, I do reverse, there we go, and there we go. So this is, so it returns a sequence of items in a collection in reverse order, and it's not lazy. So it's not returning a lazy sequence. So this is eager. This is going to happen straight away, which is fine. That's exactly what we want. We're not dealing with very big data structures here, so we don't need to lazily go through and only do certain parts of the data structure. We haven't got like millions of elements in our data structure. They're only quite small, so it's fine to do something eager or strong evaluation. And it's returning a sequence. So it's interesting that it talks about a sequence. It's not going to just return. So if we have a list, sorry, if we have a vector, then it's going to return just a sequence version of that, which is going to look like a list, as you can see in the example above. And it talks about sequence, and we should keep that in mind as we're going through, because it is, as I mentioned, it is relevant to the string example we've got. So if we reverse race car, then we can see that what the problem is here as well. So we're actually getting we're getting a list. So we started with a string, and now we've got a list of individual characters, and the backslash just means that that is a character. We can see that if we do we do type properly, and we do backs. Where's that on my keyboard? Oh, there it is. And so we can see it's a character, which is different to a string, which is a string. So that's a Java-like string. Oops. All fingers today, sorry. Excuse me. So we've got type, a type of R. So this just tells us the underlying type that Clojure will assume. So, yeah, Clojure will kind of like determine, as it's reading the code in, it'll determine what type it is. So if it's a slash in front of something, we'll assume it's a character, a Java lang character. So we're using, because we're running Clojure on the JVM, it's going to use some of the features of that language to represent the data types. And it's just using a Java lang character. String is just using a Java lang string. And both these namespaces, like Java lang, is always part of a Clojure project. So we don't need to import anything to just be able to use them as well. There's a question for Piotr. How do we make the eval results to stay in the buffer as a comment? Okay, right. Yeah, so I set up, I actually added a key binding from here. So if we evaluate something, so I go in and open up the evaluation menu and evaluate, and in Spacemax and in Emacs, it's cider eval the def to a comment. So it basically just prints out a comment on there. Some editors will just keep them around anyway until you toggle them off. I think that's what Visual Studio Code does in Spacemax and Emacs. Well, this is basically cider. I think, yeah, so the function's insider, and I just added a key binding to the spacemax closure layer for comma, because we use because we use semicolon for comments. I just thought it was a good name to use. Okay. Hopefully that answered the question. So, so we can reverse things, but we have to do something with cool. We have to do something with string to be able to manage that. Otherwise, we're because if we now do the comparison, so let's compare values together. So we can just use the equals. This is just going to compare two values together. So we've got we've got our list of numbers here. And we're using the quotes there just to inform Clojure that we don't want to call the one as a function. If we didn't have the quote there, that's what it would do. It's just saying quotes, just treat this as data. And if we compare that with calling reverse on the same thing there as well, then we can see if these two are equal. We know that they're not. Let's evaluate that, and it's false. So that's good. That's the answer we are looking for. So that kind of works. So just a simple equals works in this case. However, if we do race car, you probably already realized that this is not going to work. Yeah. It's not going to work because we've seen that race car as a string and race car as a sequence of characters are not going to be the same. So even though race car does reverse things and it's a reversible string, it's in a different format. It's a different type, so they're not going to be equal to each other. So if it wasn't for this, we could just write a function that takes in the I guess it's not really a number, is it? It's in the pattern. Let's call it a pattern. It's in a pattern, and and that can be a list or a string, and then it reverses the pattern and compares it with the original pattern, and that would work for everything but the race car string. So this would be like a very general way to solve it. And you can see that this is giving us, when we do this function, I'll change that to pattern element direction. So we got this here. Let's just change that to. Yeah, but that's not right. Okay. Almost. Hello, Puss. Apologies for ignoring my cat in the background. Here we go. Yes, you've had tuna today. What's with you? You've got more tuna left to come. Apologies. So we've got this function, and because it's we're just using a function with fn, then we actually need to put that into a list as well to be able to call it. And then we're giving it an argument here as well. And then it is returning false. So that works, but obviously if we do the same thing for race car, then we're not working okay. So we need to figure out a way to do we need to figure out a way to compare race car reversed or reversed race car in a way that doesn't change it to sequence of characters. So one way, I guess for me it seems a little bit more low-level way to do this is to just apply like sequence to a race car. So if we sequence the pattern that we're getting in, and then when we reverse that pattern, it will be the same as the thing there. So if we go and have a look at, did I put that in there? Yeah. So here's a solution. One solution I've got which works. So we take in the pattern, as it were, and regardless of what it is, we convert it all to a sequence. They'll all convert to a sequence without changing the values inside them. And then we can just reverse the number. So even if we reverse something and it produces a sequence, then these things are still going to equal each other. So if we run that, then we get magic numbers. Everything goes green. Any questions so far? No. You can be quiet, kitty. There we go. No. But I think there's a slightly nicer way, well, it's not necessarily a nicer way, but there's another way to do it that's more kind of specific. I mean, we can create, here I just created a function there, but we can also use this closure string approach. So instead of using reverse from Clojure core, so we got, oops. So we've got Clojure core / reverse, which is a general one that we can apply to any kind of data structure, but it doesn't respect the fact that a string is a string. It doesn't keep the string, it returns a sequence, which is, in this case, not what we want. But if we do Clojure string, then as you can probably imagine, there is specific functions that will work on strings that respect the string. So they'll return a string as well. So here we're returning s, which is our argument, and it returns it with the characters reversed, but it returns it as a string rather than a sequence of characters. There we go. So if we use that, so we can do a test. We can put a test in our excuse me. We can put a test in our function. If the value or the pattern we take in as an argument, if that's a string, then we can process that using the Clojure.string value. And if it's not, we can just simply reverse it. This makes it more specific, and we don't need to convert all the values, just brute force convert all the values to a sequence as well. So I think there's two options. I think it depends on exactly what you're doing, but I quite like this approach because it's kind of taking it into the context, the intent of what you're actually trying to do. So you're actually specifically reverting a string if it's string, otherwise you're just going to reverse everything. Sorry, you're just going to reverse it, the pattern as it is. You're not going to convert it to a sequence. I think I did some other experiments, but I don't think that's interesting. I'll have a look who does later on. So that's 27. So you can either take the approach I've got in here, or you can put an if condition in there and test if it's a string. I think both of those are pretty good. What are the solutions that we've got? This is kind of the same, except it's using cond instead of an if condition. I think that's quite useful if there's multiple conditions you want to base off. So if it's like if you need to do something specific for string and vector and map and set, then I think cons is quite a nice choice. I think it's not necessarily that useful for just one condition. This is just a shorter version of the sequence one. So this is just using the syntactic sugar for a function definition. This is using vec instead of a sequence. So this is a more specific implementation of kind of this line underneath. So it's converting everything to a vector. I think seek is probably nicer in this case because seek is a more general thing, or there's no specific requirement for us to convert things into vectors. So I think seek is a more appropriate kind of function in this very limited context we've got as well. I think most of these are pretty much all the same. Here we're applying list. Again, this is a bit like doing the vec. We're applying list to something, so we're basically converting the original pattern into a list, which for the string will create a list of characters. And these are just kind of bigger versions of the reverse. This is quite cool. What are we doing? Reversing a sequence and the reverse. I'm not quite sure why it's doing so many reverses, but there we go. Interesting. Cool. There we go. Okay, so let's move on to the next one. Let's look. So we're going to, as I said, we're going to skip 28. We're going to go on to 29. So 29 is get the caps. So this is a, what's it saying here? Write a function, takes a string, returns a new string containing only the capital letters. So only the uppercase capital letters, the ASCII code, which is so a certain range of ASCII codes there. Oops, showing you the answer there. Oh. Let's come back to that in a minute. So let's switch back over to Spacemax. Let's go 29. There we go. So write function. So we've got 3 tests to pass. So we've got hello world as a string. We've got another string. So they're all strings. This is a very very interesting looking string. But there's only there's only 2, as it says, there's only 2 uppercase capital letters in this string. So what are we trying to do with this? If we look at the problem, so we only want to return the characters that are uppercase for a given string, and so it's a matter of filtering out everything that's not an uppercase character. So I guess you could take the approach that you convert each character into an ASCII number, and then only keep the numbers that are within the right range of ASCII numbers that represents uppercase values, because the ASCII numbers are all in sequence. So A to Z lowercase from 65 onwards for like 26 26 characters, and then the uppercase ones are in a number from there as well. What's that, like 60, 88, so 89 onwards are all the uppercase characters of the alphabet. So we could just see whether each character is in the number range for the uppercase, and then just drop the ones that we don't, that aren't part of that. That does seem a little bit over the top, though, to convert everything to ASCII, because we're not using ASCII in any other kind of context in this challenge. So there is also something called regular expressions, which again is a nice kind of pattern matching approach. So we're not having to really transform the data, because we're going to use we're going to define a pattern of things that we're looking for in the string, and then we're going to use that to filter out and just keep the things that match the pattern. Or we could filter out, we could have a pattern that that we use that is the things that we want to throw away. So we can either do, so in this case, in the first two ones, we could just use, if it's a lowercase character, then we throw it away. But in this case, we've also got special numbers, so special characters and numbers in there as well. So we'd have to do a lot of cases there. So it's easier for us to actually say, well, okay, we'll use a pattern that represents the things that we want to keep, and use that to filter out the string. So I had some experiments to obviously we can use Clojure string to make things uppercase. So we could, if we were like to doing a lot of typing, we could do uppercase in every single character in the alphabet and to see if they're comparing. We could create a map of all the individual uppercase characters and see if it's contains within the map. This is kind of what I'm starting to do here, although contains, it doesn't really work how you expect it. It's kind of based on more of an index, and in this case it's not supporting this. So I played around with contains and some, and wasn't really getting what I wanted to do because it wasn't matching. And it didn't like us using my pattern as a function in this case. So because that's what filter is wanting for, so I'd have to I could write my own little function with filter to use this irregular expression. So I should explain the regular expression later. In Clojure here, this is our regular expression. Let's do that. Regular expression, and this is also termed as regex for short. And in Clojure, so if we forget about that for a second, so basically defining a string that represents our pattern. And in this case, we want all the values, all the characters, all the uppercase characters from A to Z, and as many as there are is what the plus is denoting. And then we turn this into a regular expression. You turn the string into a regular expression that the Clojure will interpret as a regular expression by putting this hash in front of the string. And so this is if you go find like a really nice expression tutorial, I think I've got one in mind. I'll put it in the link in the show notes. You can do very simple things, very powerful things, very simply using regular expressions. In this case, I mean, I could also do like then in there, and it would come back all the uppercase and lowercase characters as well. We just want the uppercase ones in this situation. And when you see something that's got a hash in the middle, it's the Clojure reader. It's an indication to the Clojure reader that it wants to treat it in a different way. So rather than just treating this as a string, it's going to treat it as a regular expression pattern. So that's what we're using with these functions here. And then where did we get to? So I started playing around with filter and contains and stuff, and I didn't quite get what I was looking for. Then I came across, then remembered something called reseek, which is a really nice function. The description for that. So this is returning a lazy sequence. So we can also use reseek on a very large piece of text or a large piece of data structure, and we can kind of optimize how we're doing. So we don't need if we were processing a book, for example, and we wanted to process certain elements of a book, then as soon as we got to a certain point, we could stop, and it would be kind of efficient to be able to use reseek in that respect. And so it returns a lazy sequence of successive matches of a pattern of strings. So it's taking this regular expression and a string as its arguments, and it will use. It's actually using Java util regex underneath. So that's quite nice, and this is going to be pretty optimal. And then it basically creates a new sequence with the matching pattern. So it's like a filter, but on a slightly higher abstraction level in there. So it's taking this regular expression and just returning the values what we need. So here we can see it's returning A and E, which is the capital letters. So that works. And it's returning them as individual strings, which is okay. So we don't have to convert them from characters to a string. So if we go back to our initial tests, you see that when it's running it, the results we're getting is a combined string. So we're not getting the individual strings, we're getting combined strings. So we will need to address that. And so we can do that. Oops, let's go back and just go get the example test. I find it's always useful to use the test data that 4Clojure gives you. Oops. Yeah. If we reseek this, oops. Reseek string. Let's grab the pattern. Copy that into there, and then we do that. And so we get the individual characters there, but we want to be able to have that as a string. If we take that result there, and if we try to join it with string, what does that give us? I got a feeling that this is going to give us a string of the list rather than doing what we want. Oops, yeah, so it's, actually, I've got a syntax error there, didn't I? Yes. You spot what my error was? Oops. I've just jumped into the code of where is it? Code of the REPL function. Oops, I didn't mean to do that. Sorry. So I've got a list there, and it's trying to evaluate h, the string, as a function. So I'll just put a little quote there, and that should fix that issue. And so that's just turning the list into a string rather than combining the individual characters as a string. So that's not what we want. So there is, we do have two functions, one called reduce, which will help us take the values of a collection and combine them with a given function. So here we're passing in the function and the collection, and it's basically going to take those values and combine them. So if we have, for example, reduce plus, which is always a simple example, and then we've got a collection. I'm going to use a vector, but any collection will do. And so this is just going to add all those values up and give me a total for those values. So it's basically reducing all the values, all the elements in the collection by using a specific function. So it's just combining them all and doing plus. So we can also do reduce string over this so if we reduce a string over there, then we should, yes, there we go. Then we get our combined characters. So it's basically taking each of the individual each individual strings and passing them in turn to string and combining them as it goes along, and then reduce returns the result. Yes, and then I think reduce also has a very similar function called, there's also a similar function called apply, which does the same thing. there is a subtle difference between the two, and I do have there is a 4Clojure exercise I'll come in a later video where I'll kind of demonstrate the differences. There can also be some slight performance differences as well between the two, but conceptually they work exactly the same. But there is some interesting usages of apply and there is some interesting usages of apply and reduce to kind of get the same. You can get slightly different results. So what I've done, I kind of created an anonymous function, the short version of this, basically created a function, and it's going to take in a pattern, and then we're going to apply a string, the string function, to the result of reseeking of the pattern. Copy that. And it's and then it applies that to the pattern itself. So that's the normal syntax for defining a function in line. You could also define this as a defin if you were going to use this for multiple. In multiple, you can call this from multiple functions. If you're just using it in line, you can use this FN form, and you can also use this shortcut. So again, we're using the hash to say that this isn't just a list, this is a definition of a function. And so it's going to allow it to take in an argument, and that argument is going to be represented by the %. And so these two pieces of code are identical. In fact, when Clojure reads this, it will convert it into this code as it goes through as well. Yeah. Oh, join. Oh, join's an interesting one. I hadn't thought of join. That's quite a nice one. Again, I quite like the idea of join. So mention that in the web chat. So rather than using apply string, we could just use Clojure join, Clojure.string.join, which I think is quite nice because it speaks more to the intent. String join. So we do that. And then let's just see if 4Clojure like that. So I've got mine. So this is apply string. It's terse. It's quite short. It's generally okay. I think I quite like this version. Here it's more expressive in telling you what it's trying to do. It's trying to join the strings together. Let me just check, see if I actually got that right as well. Yeah, there we go. Cool, it works. Yeah, I quite like that one. It is longer, but sometimes the shortness of a code does not necessarily make it better. Sometimes it makes it less readable, and if you come back to code after a while, or somebody else looks at your code, then it's nice to have more readable code, even if it's a few characters extra. Okay, any more questions on that one? Nope. Okie dokie. Right. So we've done that one. And 30, compressor sequence. Oh, let's have a quick look at the solutions. If there's anything else that's interesting in there, it's all pretty much the same as what we've come across. Oh, interesting. It's just filtering on a character, his character uppercase. Okay, interesting. Is that using I think that's using the Java static method for character. I guess I need to go and check that, but that might be what that's doing. It is possible to use that. Oh yeah, Yeah, it's better than regex. Oh yeah. I can see that this is more specific than regex, especially if you're not familiar with regular expression. Then this is quite a very expressive way of saying you're going through character and is it uppercase. So it is very expressive in that respect. I guess it's something you would do in a code review to see whether, or ask your team whether they are happy with using regular expressions or not. I guess it depends on how complex the pattern is you're wanting. If it's a very simple, just a case of saying whether it's uppercase or lowercase, then this is good. If it's a more complex thing, then you either have to write your own function or use a regular expression pattern that was more intricate than that. And I think I do have an example of one regular expression I've used. Let me just switch back to that briefly. So let's go to my Clojure through code, which is there. If I open the file, so there we go. Let's make that a little bit bigger. So here's another example of reseek with a regular expression. So here we're getting all the lowercase characters, all the uppercase characters, and any numbers between 0 and 9. And then we're also going to strip out the apostrophes because we want to test whether like English words are there, and it's just going to join those. And there's going to be more words essentially. So this is another way to do that, which is a little bit harder to express in a single function. I don't think there's any functions there that kind of says just look for. I mean, there's nicer variations on the regular expression. There's something that you can just put word in there, and it'll all match your words and boundaries and so on. So you kind of make some of the regular expressions more easier to understand. But yeah, the more complex the pattern you want, the more likely you're going to use reseek, I think. Feedback. Okay. Let's see. Is anything else I'm going to cover? Yes. Replace. Interesting. Okay. So in case you hadn't come across this before, in 4Clojure, if you actually logged in, you can actually go into the top users and go and follow people. That's how I'm getting these solutions. It's a little slow, but you can go in and you can basically just go and select and go and click on these people and go and follow them, and you'll get their answers, assuming that they've done an answer for that particular problem you're working on. Bobby Towers, follow, he's quite good. He's been doing lots of stuff. There's Mike Fikes in there and quite a few other people. Most of these people have done all or pretty much all of the problems solved. So that's yeah, it's always interesting to see other people's solutions in that respect. So that's going to sleep. So let's go on to 30. 30 is compress a sequence. I think this got me stuck for a little while, and then I started looking around at different functions. But let's have a look, see if I remember how I did this now. So we want to write a function, and it's going to remove consecutive duplicates from a sequence. And so yeah, here we've got lots of E's and lots of R's and lots of Y's. Here we've got repeated numbers, and here we've got repeated vectors inside the vector. So this is a vector 1, 2. This is also a vector 1, 2, and so is that. So we want to basically, I want to basically show. I guess this is part of like relates to like cleaning data, which is obviously one of the things we have to do. In a lot of our software systems, the data we get in or some of the data that's being generated is not necessarily clean. We need to tidy up. So it's a nice kind of intro to doing that kind of thing with Clojure. So let's have a look to see what we got up to. 30. It's a little bit bigger. Okay. So we've got 3 tests. We've got tests with a string, tests with just a vector, and then a vector. So this, I guess, makes it interesting, but we're still kind of dealing with individual vectors. Oh, and they need to be consecutive. Ah, that's interesting. So if we look at the last one, so we need to get rid of 1, 2 here and 1, 2 here. We just need a single a vector of 1 and 2. And then 3 and 4 is different. And then although 1 and 2 is the same as the first 2, it's not the same as the previous number. So we say if something is the same as the previous element in the collection, then we drop that. And if it's different, then we keep it. So that does kind of feel very iterative. And I guess if you don't know a lot of the closure functions, then there's a tendency to say, okay, well, I'll just do a loop recur version of this and just loop around and go around and check each character, and then if the new character I get is the same as the previous character, I'm going to throw that away, and then I'm going to get the next character, and then go around and around and around and around. So you could do that in a very I guess it's still functional, but it's kind of using loop recur is a little bit more iterative, a little bit more prescriptive in how you're doing things. But sometimes you need to do that. So what did I do? Oh, I did that as well. I'm not going to write I will write a loop recur version of this at some point and add this to this section just as a kind of demonstration of just kind of how wordy, how lengthy that would get. But there's a really nice function called partition, and there's several variations of this as well. So if we can have a look at partition. So here we're dividing up a partition by 2. So we're going to take these numbers, and we're going to get the first 2, and then the second 2. Second pair and the third pair. So it's basically converting these into pairs of numbers. And then each of these we can compare to see whether they're the same or not, and the same or not. But then we'd need to kind of compare whether these the numbers are the same as in between those 2 as well. So a slight variation of, instead of just putting them into groups of 2, we're still going to put them in the groups of 2, but step through them once. So let's explain that a little bit more. So we're going to take the first pair, our first 2 values, and create a pair of those. Then we're only going to step through it by 1 element in the collection, and then this is where we're going to start our next partition. And then we're going to create another partition of 2. And put them in there, so we get 1, 2, and then we're going to go to the step another way through the collection, and then create another pair, and so on and so on. So we're actually just breaking the numbers down into more numbers, but then we can individually compare to see whether the numbers inside here are the same. And if they are, then potentially we want to get rid of them, or we know that it's not something we want to keep, except for maybe the very first time that we do it. Obviously, we probably want to keep those, because if we just drop it, we'll lose a number. But if we want to compare, so we can compare 1 and 1, but then we want to compare 1 and 2, and so on and so on. And when we compare 3 and 3, then obviously we want to lose the second 3. Here we want to lose the second 2, and so on. So we can filter out something. So previous examples we use filter with a simple function, filter odd, and if we've got a collection of 1, 2, 3, 4, 5, then this is going to obviously filter out so only odd numbers, only where odd is equal to true. are we going to keep those values, and where filter comes across an element, and when you apply the function to that element, it's false, it's going to drop that function, drop that element. So applying odd will just return the odd numbers in this case. So that's how odd works. And then, so we're going to filter these out. So we've got our, this is the function that we've got to filter something. So we take each of the elements, and each element is the collection of two values. And so we're just going to treat these as a simple sequence, and say that so we've got a function that takes in two values. Oops. And it's going to say basically not equals. Instead of the equals function, we're doing not equals, and we get the sorry, we're just taking in a collection now. And then we get the first of the collection. And then the second collection. So that's essentially what we're doing here on this line. So this is a function we're going to use for our filter. This is our odd thing. So it's basically going to compare these two numbers. So if we give it this thing first, if we give it this this collection here, it would see whether this is true or not. Let's put that into a bit of code. So if we're going to call that function, and we call it with an argument, and I'm just going to use a vector because it's easier. 1, 2. So it's returning true because these are not equal to each other. And if we did obviously a 1 and a 1, then we would get a different result. We get false. So it's a value we don't want to keep because it's the same. So I guess if we were going to give this a name, we would get like a okay. Naming is hard, so sometimes it's quite useful to have a function that you can use without having a function name. Name them, let me know. But we're using it in line, so we don't need to give it a function. We're not calling it ourselves anyway, so we don't need to give it a name in this case. Okay, so we've got a function that we can use with filter that will tell us whether those values in each of the partitions in our collection are false, and it's only going to return the ones that are true. So there we've got that twice. So here we've got our filter, and there we go. We're partitioning it, and so we've got 1, 1, and then the second one has gone. So we've got 1, 2, which is correct because we just want 1, 2, and then we want a 3. So the 3, 3 is no longer there, and the 2, 2 is no longer there. The 2, 3 is still there. So even though there's already 2s and 3s in there, they're not consecutive, so we keep that one. So we've got closer, but we're still not quite there. So we could flatten it. I think I said not to use flatten earlier on, but again, it's quite a blunt tool, but we can also see that flatten is not right. So actually, this is an interesting example of using flatten where it's not really appropriate because we're not really taking into consideration the context of why we're trying to flatten something, what we're trying to do with it. But we are fairly close. We are getting close to what we actually need to do, and so we can do a more specific kind of filter. We can write our own little function to do a specific kind of filtering here, I think we could, oh, actually, I'm changing the. I obviously didn't come up with a better way to do filter. So what we're doing is partitioning by something by, in this case, we're partitioning by identity. And this is, oh, okay, no. Okay, is that because there's, let me just check what I did for NASA. Just check where I'm going, the destination. Oh, okay, yeah. So by identity, yeah, so this is, yeah, so switch to partition by identity. It's giving a similar kind of thing. We're still going to, oh, yeah, so partition by identity gives a much more specific thing. I think also by identity, it allows, yeah, let's use a variation of a, yeah. So we can get the first value. Okay, right. So we're basically, this is how I'm doing the filter. I'm doing the partition. I've still got it like a partition thing, but then we're getting the first value from each of the elements by mapping over each of the elements with the first function. So we get 1, 2, 3, 2, 3, which is the correct answer in this case. And I think I'm using this because, yeah, we need to do this because we've got different types of collections that we're using. So that worked for just a simple vector. It also looks like it's working for a vector. But it doesn't quite work with string because we've got this, yeah, this situation where we're converting into a sequence of characters instead of the string. But if I switch back, yeah. One thing I got so carried up in solving this, I actually forgot to go look back at the test. If we actually see a test, we're actually using apply string in as part of the test code. So the result of this, applying that is, if we do get a sequence of characters, then this is taken care of because it's applying string to turn that into just a string. So our partition by identity does work in this case because that's a suitable answer to return because the code is going to do that. I did delve into actually how to do this and got a bit carried away with that as well, but it was all really interesting. Let's see, and use compressed, but essentially, yeah, I can just map first of a partition by identity on a collection. And you might see in the documentation that XS is often used as a collection. So we use X as a value, a single value, and X as a sequence or a collection of values. That's something I in the documentation closure. And yeah, I did get a bit carried away with that, but I'm not going to go through that. I'll leave that in for you to go and read if you're interested. But there is a very specific kind of way to go through this using different things. Using compressed, which is taking care of the string basically. But I realized I didn't need to do that. There we go. So in summary for that one, it's a nice kind of example of using partition to solve the problem, which again gives a nice level of abstraction to doing things. You're not having to go through loop recur through everything, even though it's quite a sequential kind of problem. You're having to process the collections sequentially, essentially. but that doesn't mean you have to do a loop recur in Clojure. You can use functions like partition and partition by to generate all the permutations of those things and then just compare. So you don't actually need to keep the state of the previous value as you cycle through things. You're just basically creating a new data structure that allows you to do the comparison that you want without having to worry about managing state and managing an accumulator or like what was the previous value. You can just compare compare the existing individual elements because they are comparing previous to last already. So this is something that took me a little bit to get into Clojure, but it's a nice way to think about working with data. It's a very functional approach. It's a very clean and actually quite a simple approach. Even though you're generating more data, you're actually making your algorithm simpler. And this is something I've come to appreciate as part of Clojure, is if you can transform your data structure into a way that makes your algorithm simpler, then overall your code is much simpler too. There we go. Any questions? No questions, seems. So let's just have a quick look at the solutions and then we'll wrap it up there, I think. So that's my solution. Yeah, somebody's using compress. Well, basically their function is called compress. And actually, so that's a good name, actually. I might use that as, as the name of that. And then it's checking to see whether there's an empty string, and then it's kind of getting the similar kind of thing. It's got a it's got a guard condition, I guess, here to see whether we're dealing with the empty string. So that might be quite useful, especially if we're not able to control the quality of the data coming in. It's quite useful to do a little bit of defensive programming. In this, obviously, in this 4Clojure case, we have full control over the data that we're using with this function. And then it's just it's using cons to pull things in. Okay. So it's just basically constructing a new sequence using the first and then the compression of rest. So this is actually doing, this is basically doing a loop recur thing at a slightly higher level. And it's just basically got a function that's calling itself, so it's iterative, so iterating through the collection and basically reducing it down to a smaller collection of just the specifics we want. That's the same as mine. There's a few variations. I think that's yeah, it's remove instead of basically using partition. And it's specifically removing values from that and then concatenating everything back together again at the end. So you might see things like mapcat around there as well. So there we go, there's a mapcat. Oh, that's quite interesting. Distinct. So mapcat on the distinct. So yeah, this is, oh, actually that's quite nice. I like that. I might add that to the discussion. So it's basically, it's partitioning by identity and the same that we were doing. So we don't need to specify the 2 and the 1. We're just partitioning it by the values. It's going to group the values together. And then it's only going to it's going to create a new collection by concatenating those values that are distinct. So if an element's distinct, so if the values inside the partition are the same values, then it's going to throw them away. But if it's a value of 1 and 2, it's going to keep that and include that in the new collection it concatenates together. And so mapcat is just basically mapping concatenation over the results of that, but using a function in this case called distinct to decide how to which elements you're going to include in the new collection. That's quite a nice one. I'm going to keep that one. All right. Thank you very much for listening. And if you've got any more comments about what we can do as a study group, anything you'd like to learn, please let me know. We'll hopefully continue with the consuming APIs next week. And hopefully I'll eventually build a nice kind of website for the Clojure study group. So it's a lot easier to find the videos than hunting through YouTube. Thank you very much, and see you next time. Thanks. Bye. Bye.